Hi children, up to now we discussed IIT mains physics live classes I am giving to you. So up to now I discussed in kinematics. Kinematics, first one rest, motion, both are relative. Next distance, displacement, distance, displacement, scalar, vector. Next speed, velocity, then average velocity, then instantaneous velocity, then uniform velocity. See, I discussed all the things up to now in kinematics chapter. So then also I discussed acceleration, next average acceleration. Is it or not? Yes. Acceleration, average acceleration. Next, I discussed equations of linear motion. Equations of linear motion. So equations of in these equations I discussed v equal to u plus at. Second one is equal ut plus of at square. See, up to now I discussed these things. So first one is rest motion. Rest and motion are relative. I discussed distance. This is a scalar. Displacement. This is a vector. So depends on distance. Speed is nothing but distance by time. Velocity, displacement by time. Then there are types in velocity. Average velocity, total displacement by total time, like that. Instantaneous velocity is nothing but at particular instant of time how much velocity is there, that is instantaneous velocity. Then I discuss uniform velocity throughout the journey. If the velocity, if it is same, then we can say the body is traveling with the uniform velocity. Then I discussed acceleration is nothing but change in velocity by change in time, velocity by time. So rate of change of velocity we can also define like that. Then average acceleration. So I discussed in last class equations of linear motion. Linear motion means nothing but only 1D motion. Either it is going x, either it is going in y direction, either it is going in z direction. Only we have to take only particular one direction. So in particular one directions, so these are the equations of linear motion. That is first equation v equal to u plus at. I discussed this formula. Then I given some problems to you. I explained also. So next equation is equal to ut plus half at square. This is also one more equation, linear equation. So here this is the displacement, this is the initial velocity, this is the acceleration, this is the time. I explained to you. So I am discussing one more formula here. So here equations of linear motion. Equations of linear motion. Linear motion I already explained to you. This is 1D motion. See, either it is going in x direction, the body is traveling in x direction as it is going in y direction. So it is moving like this. Whatever it is, you have to take only constant in particular direction. So for this I am giving one more formula to you. Already I explained v equal to u plus at s equal to ut plus of at square. These equations we can apply when the body is going with the uniform acceleration. Then only we can apply these kinematic equations. So we can apply when if a is constant throughout the journey. If a is constant throughout the journey. Next, so here v square minus u square equal to 2as. This is a one more equation. This is the third equation here. So here also I think we have here four variables, that is v, u, a, s. What is v? Already you know, final velocity. U, this is initial velocity. A is uniform acceleration, uniform. Then s is nothing but displacement. See here in this question, in this formula, v square minus u square equal to 2as. 2as, that is v is final velocity, u is initial velocity, a is acceleration, s is displacement. So by using this equation, we can find final velocity, we can find initial velocity, we can find acceleration of the body, s is the displacement also we can find. So this is the third kinematic equation of linear motion, of 1D motion. So here we are using for 1D motion this equation. Then we can apply 2D also is there, but we are discussing now only in 1D motion. So here final velocity, initial velocity, 2 into acceleration and into displacement. Then okay. So for this one I am giving one problem to you. For say I am writing one problem. A car traveling with 2 meter per second. A car traveling with 2 meter per second and reached its velocity 5 meter per second. What is the displacement? What is the displacement of the car which is traveling 2 meter per second square? Right, take it as 1 meter per second square acceleration. This is a question. See, what is the question I given to you? A car traveling with 2 meter per second and reached its velocity 5 meter per second. What is the displacement covered by the car? Covered by the car which is traveling 1 meter per second square acceleration. Which is traveling with, we can use with 1 meter per second square acceleration. So here the question read first one time. A car traveling with 2 meter per second, that is initial velocity of the car, reached its velocity to 5 meter per second. This is the final velocity of the car. What is the displacement covered by the car? So displacement, how much it has taken when the car is traveling with 1 meter per second square acceleration. These are the information we have. So here v is nothing but final velocity. V is nothing but final velocity Next, u is initial velocity. U is initial velocity. A is acceleration. S is displacement. Is it clear you? Is it audible to you? Yes or no? If it is yes, is it audible to you? Is it visible to you? Yes or no? Message me. Okay, now. See, I am explaining what is a question. A car traveling with 2 meter per second and reach its velocity 5 meter per second. What is the displacement covered by the car which is traveling with 1 meter per second square acceleration? Here, V is final velocity, A is U is initial velocity, A is acceleration, S is displacement. Which are the physical quantities there in the equation? So I am substituting here V equal to here 5 meter per second, 5 meter per second. U equal to 2 meter per second. Is it? Then this will be A equal to displacement. A equal to 1 meter per second square. So my question is, how much displacement covered by that car? So I want to find, yes, I want to find, yes, that is displacement of the car. So I am simply, I will remove this. I am rubbing this. So I am substituting these the values. I will do problem here. So here U equal to 2 meter per second, V equal to 5 meter per second, A equal to 1 meter per second square. What is this? This is the information we have in this question. So I am substituting. B is nothing but 5 square minus U 2 square, that is equal to 2 into A is nothing but 1. So we have to find, yes, this is the displacement covered by that car which is moving with the initial velocity 2 meter per second, final velocity 5 meter per second, and with the acceleration 1 meter per second square. So yes, 25 minus 4, that is equal to 2 1 are 2, 2 into S. So here you will get 21 into S. S is nothing but 21 by 2. You will get 10.5 meter. This is a simple solution we have. If you know simple calculation, if you know simple calculation, that is S equal to 21 by 2, you will get 10.5 meter. So if you know simple mathematics, you can do this problem very easily. See what I did here. A car traveling with 2 meter per second and reach its velocity 5 meters per second. What is the displacement covered by the car which is traveling with 1 meter per second square acceleration? Okay. Now I take here U equal 2 meter per second, V equal 5 meter per second, A equal to 1 meter per second. Is we have to find. So V square minus U square equal to 2AS. I calculated is equal to 10.5 meter. So is there any problem with this equation? So this is the equation V square minus U square equal to 2AS. See, V equal to V square minus U square equal to 2AS is nothing but V is the final velocity, U is the initial velocity, A is the acceleration, then S is the displacement. So we can find displacement covered a linearly moving body. We can use this equation. So we can use second equation also, S equal to ut plus half t square also we can use. Why we are not using? Message me. So there also we have this equation also there. Here also we can find displacement. Here also we can find displacement. Two equations we have. Which is equation suitable to you? This equation. That is we have to find the difference how we are using these two equations. So in two equations we can find displacement covered by that body. So which is better, which is suitable to this information? So why do you know? Just message me here. if we, is it suitable this equation, is it suitable this equation for this question, for this question? Come on, message me. Which is very good, first one or second one? For example, this is a second equation, this is third, second or third, which is better, second or third? Kinematic equation, second or third? See here, this third equation is suitable to you because in this question, so here we have displacement is equal to ut plus half a t square. U is initial velocity, t is time. But in this question there is no time. We are not mentioned any time here. But in this question we have the initial velocity, final velocity, acceleration. Then we can easily find the displacement of that car. If in this equation if we have a time, then we can go for this equation. So that is the difference between when which equation is suitable, which equation is suitable to solve the information, to solve that question. So that is the depends on our thinking. So just I will give here. See, we have, oh, this is the second, one more equation, b equal to u plus 8. So these three equations which is suitable to that information, we have to read the question one time, then from that question which information he has given, what is we have to go, we want to calculate. So that when we know those things, then we can use from these three equations we can use which is suitable. So that is, so here if you want to use this one ut plus of 80 square, we have to know at least initial velocity, time, acceleration, then we can find displacement. But here initial velocity, final velocity, acceleration, there is no time in this term, but this in this equation time is there. So every equation it has its own it has own importance. When we are using according to situation, that will give, depends on our thinking nature, then depends on that information. So we have to use these kinematic equations. One more equation is there, 4 kinematic equations for linear motion. For 2D motion also we can apply, but here we are using only linear motion, that is 1D motion. So these 4 equations, so up to now I discussed only 3 equations for you. V equal to u plus 80, then s equal to ut plus half at square, then third equation will be v square minus u square equal to as. So in 3 equations what we have, initial velocity u, final velocity v, then acceleration of the body. Acceleration for these all equations, for all linear equations, acceleration should be same, that is constant. A is uniform accelerated motion, bodies only. We can apply these 4 equations. First one is u, v equal to u plus 80. Second one is s equal to ut plus half 80 square. Then third one is v square minus u square equal to 2as. So one more equation we have, that is nth second displacement. So this is somewhat different. So here fourth equation, Sn equal to, this is nth second displacement, S in subscript n. So here this shows nth second displacement, u plus a n minus r. This is the fourth equation we have. So what is information we can get from this equation? That means Sn equal to, so I'm writing here Sn. So nth second displacement, nth second displacement, u equal to nothing but initial velocity, u equal to initial velocity, a equal to acceleration, a is equal to acceleration. Then is here n denotes nth second, that's it. See, first second, second, third second, fourth second, like that, nth second. So this the variables in this question. Sn equal to u plus a of n minus of, that is equal to Sn equal to nth second displacement, u is initial velocity, a is acceleration, so n equal to nth second. So you just copy this formula, fourth equation, then I will explain how to use in problems to solve problems. Come on, copy it. If you copy, just message yes. Okay. Then here, so this is the fourth equation. What is that? Sn equal to u plus a of n minus of. This is the fourth equation. So I will give here one problem to you, then you can understand easily. A body is traveling with 5 meter per second for 5 seconds. A body is traveling with 5 meter per second for 5 seconds. Otherwise we can say a body is traveled, no problem. For 5 seconds it is traveling. Okay, it has uniform acceleration 2 meter per second square. 2 meter per second square. So this is the information. So what is the displacement covered by the body in its third second? This is the question. So we have here, look here, a body is traveling with 5 meter per second for 5 seconds. It has uniform acceleration 2 meter per second. What is the displacement covered by the body in its third second? So the question will be like this. I am discussing here. This is the body. This is a linear motion. For example, this is the body. Okay. This is the body. It is moving with u equal to 5 meter per second with the acceleration 2 meter per second square. Is accelerating with 2 meter per second square. It travel for 5 seconds. So we have to find S3, displacement of the body in third second. Displacement of the body in third second. So for that one, we have to calculate here. So here S3, S is displacement that is in third second. The formula is u plus a of n minus of. S3 equal to u plus a of n minus of. U is equal to 5 meter per second. A is 2. Nth means here we use third second. Third second is equal to n equal to 3. Substitute like that. 5 plus 2. 2 3 is 6 minus 5 by 2. So 5 plus 5. 5 plus 5. How much you will get? Here 10. So up to here it is okay, I think. See, S equal to finally you will get 10 meter. So that is S3. So I explained here what I did here. A body is traveling with 5 meter per second. That is initial velocity of that car or a body or bus. So 5 seconds it traveled. T equal to 5 seconds. So A equal to 2 meter per second square. So we have to find the displacement covered by the body in its third second. So what happens here actually? We got the answer, but we have to discuss. So what happens here? So this is a traveled 5 seconds it traveled. 5 seconds it traveled. First second t equal to 1. In first second it traveled for 5 seconds, but in 1 second displacement covered by that body is s1. Then in t equal to 2, that means second displace covered by that body s2. In third t equal to only third second, third second, so displacement covered by that body s3. Then t equal to fourth second, so s4. T equal to 5, s5. So displacement, that means displacement covered by the body, it traveled from here to here, so it traveled for 5 seconds. So what I want to calculate in third second displacement. So for example, we have to split the total total displacement in 5 partitions. So in first second displacement this one, then second displacement in second, that means second how much the body traveled, that is s2. In third second how much distance covered, s3. Then how much distance covered in fourth second, that is s4. How much distance covered, displacement covered by that body, that is s5. So this is the fourth equation, somewhat different from three equations. In first three equations the time is fixed, that is total traveled by that body in 5 seconds, in 6 seconds, in 5 seconds, 10 or 15, it is fixed. But here in first second second displacement, third second displacement, fourth second displacement, fifth second displacement. So in particular 5 seconds travel time, so we have to split in first second displacement, second displacement, third second displacement, fourth second displacement, and fifth second displacement. So this is the difference from top three equations. So just you write, copy it. Okay, if you complete it, if you copy it, then I rub it. Message me yes. So I will explain here essence nth second displacement. I am repeating here. So total, for example, a body traveled for 10 seconds. 10 seconds it traveled for 10 seconds. For 10 seconds, so in 10 seconds 1 second is there, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to split it. First second, second second, third second, fourth second, fifth second, sixth second, seventh second, eighth second, ninth second, 10th second. So So here S1, actually the body travel for 10 seconds. So this is the displacement, covered by that body in first second. First second, this is the displacement. Then in second, that means t equal to 1, t equal to 0 here, t equal to 1. In 0 to 1 seconds, it travel S1 displacement. Then here t equal to 1, here t equal to 2, t equal to 1 to t equal to 2, that is second to second S2 displacement. Someone typical here, you have to clarify, you have to listen very clarity, then you can understand well. So this is the t equal to the here t equal to 3 seconds complete. 2 seconds start, here 3 seconds start. So 2 second start and complete here, start here and complete here. So that this displacement covered by that body in third second, S3. Then in fourth second, so this is the fourth second, S4. This is the fifth second, S5. Is it first second, that is 0 to 1 second, 1 to 2 second, 2 to 3 third second, 3 to 4 fourth second, 4 to 5 fifth second. Then here t equal to 6, S6. Here t equal to 7, S7. T equal to 8, S8. T equal to 9, S9. T equal to 10, S10. So final total displacement covered that body is equal to S1 plus S2 plus S3 plus S4 plus S5 plus S6 S7 S8 S9 S10. So here you write a statement here. Total displacement equal to displacement covered in first second plus displacement covered in second plus, like that up to right, displacement covered in 10th second. So that is equal to S1 plus S2. You have to first write these, then you have to draw this figure, then finally you write this one. So total displacement. Simple. What is happening? We divided into 10 parts. In first second displacement, second displacement, third second displacement, fourth second displacement, fifth second, sixth second, seventh second, eighth second. That means in particular 7th second, how much displacement, that is we can denote is S7. S10, see S10 means t equal to 9 to t equal to 10. This much time, how much displacement it covered, S10. So here 0 to 1, S1. This is in first second, initially first second displacement. This is finally last second displacement. We can call it as, here also we can call, so S1 in first second displacement. In first second, here this is in last second displacement. So S1 is in first second displacement, S10 is last second displacement. Just you copy these things. When we do problems, we have to know these things. Just copy all the things. After that, message me yes. Come on. Okay, did you copy? Yes. But in this so this question we can apply when we can apply these questions. So where the body is moving with uniform acceleration, the body is moving with the uniform acceleration, then we can apply these equations. That is very very important. So I am writing here one problem to you. A body traveled a body traveled with 2 meter per second and 2 meter per second square acceleration for 10 seconds. Find its ninth second displacement. So how much see we can ask like this also. Find its 90-second displacement also. Otherwise find the displacement covered by the body in 9th second. Same meaning. This is a repeated question. I given the question same. Just you write here. A body travel with 2 meter per second and 2 meter per second square acceleration for 10 seconds. Find its 9th second displacement. Find the displacement covered by the body in 9th second. In 9th second displacement or displacement covered by the. Okay. So we'll do this question. Just you copied and message me yes or no. Is it visible or not? Is it audible or not? Also message me yes or no. Yes. Okay. So we'll do problem here. So here uniform velocity, that is initial velocity 2 meter per second, acceleration 2 meter per second square, time equal to 10 seconds. So what we have to calculate here? S9th. S9th means the displacement covered by a body in 90 second of its journey. The displacement covered by the body in 9th second of its journey. Actually the body traveled for 10 seconds. Here to it taken 10 seconds, but we have to find here it's only in particular 9th second. That means the time starts t equal to 8 seconds to t equal to 9 seconds. So that the difference is only 1 second, in particular 1 second. What is that 1 second? In particular 9th second, how much displacement covered, otherwise it traveled by that body, by that bus, by that car, by that whatever it is, a particle. So we will find S9. So for this one we have the formula S9 equal to U plus A n minus half, U equal to 2, A equal to 2, N equal to what? You have to find 90 seconds. So N equal to 9. 9 minus half. Is it? Is it clear? 2 plus 2, 17 by 2. 2 plus 17, 19 meter. 19 meter. Is it right or not? Just check it. This is good. We calculated only the body traveled in particular 9th second. That means it traveled t equal to 8 seconds to t equal to 9 seconds. In particular 1 second, it traveled 19 meter. It traveled 19 meter displacement. So if you completed, if you understand, okay, then. So just you calculate here S1. That means you have to calculate here. I given this problem. So here u equal to 2 meter per second, a equal to 2 meter per second square. So take n equal to 1, first, second. This is the information. Yes, one you just calculate and tell me the answer first. Do it. Do it and give me answer. How much you got? 2 meter. So I will check here. For S1, displacement covered by the body in first second. In the first second. U equal to 2 plus 2, 1 minus half. 2 plus 2, 1 by 2. 2 plus 1, 3 meter. Did you get this one also? 2 meter only you got. So that is wrong answer. What you got? See, this look here. U equal to 2. A equal to 2. Then N equal to 1. So because in first second. So 2 to cut 2 plus 1, 3 meter. Is it right or not? Just observe here. Is it right or not? You did that is wrong. Here it is right. So this is S1 displacement. Like that calculate S2 displacement. Do it fast. You can understand well. If you do these problems, how we are doing, you can understand that. So calculate uniform the displacement covered by the body in second. Substitute n equal to 2. Then do the problem. Give me answer. So here, so we up to now we calculated S1 displacement, that is nothing but displacement in first second. Displacement in first second. Actually the body traveled for 10 seconds. So we calculated here only in first second. So that is U equal to 2, A equal to 2, N equal to 1. So we got 3 meter. Is it or not? Yes. Then S2. I will check. You got the answer? 5 meter per 5 meter only. I will check for S2 here. U equal to 2, plus a equal to 2 second. That means 2 minus half. 2 plus 2, 3 by 2, 2 to cut, 2 plus 3, 5 meter. Good, you did well. You did well. Why? Because you calculated, you got the answer 5 meter. I calculated here also 5 meters. So what we calculated up to here? So we calculated only S1 displacement, that is equal to 3 meter, S2 that is equal to 5 meter. So we calculated the displacement covered by the body in first second, the displacement covered by the body in second. So this is 3 meters, this is 5 meters. So you just calculate S3 here. Then go for S3. Calculate fast and give me answer fast. Come on. Here U equal to 2, A equal to 2, N equal to 3. Calculate fast. Calculate here. 2 equal to 2, A equal to 2, then S equal to 3, 3 minus half, then message me in chat box. If you completed, message me in chat box first. So this is equal to 2 into 2, 2 plus 2, 2 3 is 6, 6 minus 5 by 2. How much you got? 6 meter. No, that is wrong. See, 2 to cut. 2 plus 5, S3, that is equal to 7 meter. Is it or not? While you are doing the problems, you have to be careful. So you are simply cutting. That thing is there. U equal to 2, A equal to 2. 2 plus 2 half, 2 3 is 6, 6 minus 1, 5 by 2, 2 to cut. Then 5, remaining is the 5, 2 plus 5 nothing but 7 meter. But you got 6 meter, that is wrong. Balu, you did well, but you are missing. Is it or not? Okay. Now calculate S4. 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 Do it fast. So I am writing here S1 displacement 3 meter, S2 5 meter, S3 7 meter. Now we are going to calculate S4. You will check it after that. First do it S4 fast. Give me answer. Give me answer fast. S4. The displacement covered by the body in 4th second. 9 meter. I will check it. U equal to 2 plus A equal to 2 plus S here N equal to 4. 4 minus half. 2 plus 2. 2 4 is 8. 8 minus 1. 7 by 2. That is equal to 9 meter. Very good. You got the answer right. Next, base 4 we completed here. 9 meter. Then S5. S5. Calculate fast. Who will give the answer? S5. Do it fast. Very good. Now you are doing very nice. 5 minus 1 by 2. 2 plus 2, 2 by 10, 10 minus 1, 9, 9 by 2, 2 to cut, 2 plus 11 meter. Good. Very nice. Okay. Okay, very nice. Next, S6. Just calculate fast. S6. 2 plus 2, 6 minus half. Come on fast, do it. Message me fast. 2 plus 2, 11 by 2, 2 to cut, 2 plus 11, that is equal to 13 meter. Is it? Okay, very nice. Next, S7, calculate S8, S9, then calculate S10. Do fast 4 problems. I think S7 will be 15 meter, S8 17 meter, S9 19 meter, S10 21 meter. Is it or not? Just calculate S7, S8, S9, S10. So displacement covered in 70 second. Displacement covered in 80 second. Displacement covered in 90 second. Displacement covered by that body in 10 second. Do it fast and message me. 7 over 8. Do fast. 8, yes, 8. Very good. 17 meter in 7th second. I think it is 8th second, yeah. So I will check here. 2 plus 2 of 7 minus 2. 7th second equal to 7. 2 plus 2. 14. 14 minus 13. 13 by 2. So 2 plus 13. You will get 15 meter. Okay. I think you got all the answers. So I am giving here. Simply I am giving S1 3 meter, S2 5 meter, S3 7 meter, S4 9 meter, S5 11 meter, S6 13 meter, S7 15 meter, S8 17 meter, S9 19 meter, S10 21 meter. Now find total displacement covered by that body in 10 seconds. Up to now we calculated the displacement covered by the body in first second, displacement covered by the body in second, displacement covered by the body in third second, displacement covered by the body in fourth second, displacement covered by the body in fifth second, like that up to 10 seconds. Up to 10th second we calculated here. What is my question is total displacement covered by the body. Just add it and tell me the answer. Give me answer. Displacement covered by the body in 10 seconds. Fast. Come on, what happens? See here, 3 plus 5, 8, 8 plus 7, 15. 15 plus 9, 24. 24 plus 35, 35 plus 48, 48 plus 15. 63 plus 17, 80 plus 19, 80 plus 19, 99, 99 plus 21, 99 plus 21, 99 plus 21, 120 meter. So from this answer, what we are getting here, what information we are getting here? So that the body covered in first second 3 meter, the body covered displacement in second 5 meter, the body covered third second displacement 7 meter, the body covered in fourth second displacement 9 meter, the body covered in fifth second displacement 11 meter, then body covered in sixth second 13 meter, in seventh second 15 meter, in eighth second 17 meter, in ninth second 19 meter, in 10th second 21 meter. So finally, see, in first second, second, third second, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So total seconds, how much displacement it covered by the body, that is equal to 120 meter. So if we apply this, the fourth equation, we are getting this independent second answer, second displacements. So here we got total displacement. So I am giving homework for you. Simply I am changing here. Have you understand this one? First message me yes or no, then I will give homework for you. Is it understand? Good, bad, best. Message me 3. You have the options 3. Good, better, best. If it is good, you can message me good. Otherwise it is bad, you can message me bad also, no problem. Or message me first. Good or bad. Then I will give homework for you. Okay, good. Now I am changing homework for you today's. Depends on formula USN equal to U plus A N minus. This is the formula. Nth second. What is this formula? I discussed here. Only particular one problem, one formula only here. Nth second displacement. The displacement covered by the body in nth second. Sn. Displacement covered the body in nth second. Sn equal to U plus A of n minus of. Here is U is initial velocity, A is uniform acceleration, A n equal to nothing but in which second, that is nth second. If it is first second, takes n equal to 1. If it is second takes n equal to 2. If it is third second, take n equal to 3, like that. So up to now I discussed last 1 hour only this formula only, kinematic equation, that is fourth equation I discussed again. So I am giving homework for you. You change 3 meter per second. Just change here 3 meter per second. Then find S1 displacement covered by the body in first second, S2 displacement covered by the body in second, S3, S4, S5, S6, S7, S8, S9, S10. We have to find these all the things. S1 equal to S2 equal to S3, S4, S5, S6, S7, S8, S9, S10. So for that one, you have the information U equal to 3 meter per second, A equal to 3 meter per second square. If you have the form answer, if it is in fraction also, you leave the answer be in fraction only. Don't go for decimal. Otherwise, it will little bit complications will come. So just what I am saying is, if you are getting the answer is in 1 by 2, 3 by 4, 5 by 4, like that, leave that in fraction only. Don't go for decimal. So this is homework for you. If you copied, message me yes. today I will close the class. Ready? Message me yes or no. If you copied, message me yes. First. Okay. Then leave the class. Copy, copy, copy it. Then leave the class. Right? Bye. Bye bye.